term unstructured data refers to data that does not have a predefined data model or does not fit well into traditional relational database tables. Unstructured data typically has no identifiable structure and may include bitmap, images, text, audio, video, and other data types. Did you know that unstructured data makes up 80% of enterprise data, according to Gartner? And according to IDC, unstructured data grows at 28.8% annually as compared to structured data, with its 19.6% of annual growth. Typical human-generated unstructured data includes text files, emails, which are largely text but have some internal structure, and it's the reason why we call it sometimes semi-structured, as you remember seeing tags such as to, from, subject in emails. Social media can also be referred sometimes as semi-structured data, as it contains some metadata, for example, likes, retweets, date and author, website, mobile data, communications, media, business applications. Machine-generated unstructured data would be satellite imagery, lab reports, scientific data, for example, space exploration, atmospheric data, and also digital surveillance. By nature, a large volume of unstructured data is unverified or even incomplete. Physical quality of documents can be a further data blocker for analysis. Now that we mentioned semi-structured data, let's discuss its main component and why is it useful. So semi-structured data maintains internal tags and markings or metadata, which is a small portion of file that contain data, including origin, purpose, author, size, recipient, etc. As a result of metadata, we can catalog, search, query, even analyze documents by means of their metadata. In fact, this type of data represents about 5% of all data, but it has critical business usage cases. One of the examples of semi-structured data is XML, markup language. XML is a set of document encoding rules that define a human and machine-readable format, and its value in its tag-driven structure, which is highly flexible. And coders can adapt the schema to universal data structure and then transfer it on the web. Do you know that XML is often used to represent annotated text and also to use for lexical resources? And here's an example of a simple lexical entry. It consists of a series of XML tags. Do you notice each opening tag, part of speech, gloss, is matched with its closing tag, and together they constitute an XML element. We can use XML to represent many kinds of linguistic information, including morphology, phonetics, semantic, even discourse level. We have seen that unstructured data has a variety of formats, which creates irregularity and ambiguity problematic to traditional analytics techniques. So UDA, unstructured data analysis, emerged in the late 90s as a text mining. Early approaches treated and analyzed text as a bag of words. Text mining evolved early to use basic shallow linguistics to handle a variety of word forms, such as abbreviation, plurals, synonyms, as well as multi-word terms known as engrams, which is a continuous sequence of items. Basic text analysis, including count frequency, was also used to carry out elementary functions, such as attempting to classify documents by topic. This is an example of n-gram processing unigram, bigram, trigram, which we will cover in more detail later. As Jean-Paul Eason stated, contemporary UDA addresses issue from unstructured content by applying statistical method and linguistic rule to thematically assess, analyze, and provide insights from unstructured text. UDA can be applied to a long list of industries, from human resources to transport and legal services. Amazon is a good example of UDA success stories. Amazon is a premier online shopping destination, and it started as online bookseller in 1994. And new developments in unstructured analytics help Amazon develop detection and management of self-inappropriate reviews. In addition, purchase pattern recognition, coupled with UDA techniques, help Amazon determine next probable purchases, such as the follow on certain books by the same author in a series. And do you know that 35% of sales come in from recommendations? Another good success story from a company using UDA techniques is Spotify. Founded in 2006, Spotify is a music, podcast, and video streaming service, which was officially launched in October 2008. The company now provides digital rights management protected content from record labels and media companies. But one of Spotify's great product, powered by UDA algorithm, is Discovery Weekly. It is a personalized playlist with a music recommendation for its subscribers. And Spotify uses natural language processing to scan music news and blogs to discuss how a particular artist is mentioned there. And the company uses deep learning methods, coupled with natural language processing and collaborative filtering, to parse music blogs to detect outliers, build microgenres, and also analyze the content of playlists. So how does UDA work? In fact, UDA is a 5-step process. You prepare unstructured data for analysis, complete data pre-processing, apply linguistic and machine learning technique to unstructured document before extraction and before modeling. Then you further extract, model, and information from textual source and use a variety of mathematical techniques. Then you extract key concept clusters and convert unstructured data into categories and structure and put it in a format useful for advanced analytic. And finally, transform data into actionable intelligence to address business challenges. At the consumer level, currently we have a blend of open source and commercial software, and very common open source solutions include TM library, Genzime package, NLTK, OpenNLP. We can see 4 major drivers for the future of UDA. First is voice of the market, leveraging the voice of market to provide product and technology, innovative services to the market. Next, voice of consumer, leveraging the voice of customer to increase satisfaction and profitability. Semantic, coupling text analytic with business intelligence to create self-learning artificial intelligence. Recognizing images, videos, extracting the concept and content from them. And finally, integration of text analytics in predictive analysis. Coupled with predictive analytics, text analysis will transform unstructured text, for example, a customer email or chatbot voicemail transcript, into actionable intelligence to address the most imperative business problems that company could face in the future.